simple answer is due to angular moment. Angular moment, the moment of inertia, like mass. Point from that nut bolt, we're not applying at the nut bolt itself, right? That is why that distance and this force when multiplied together, they give something called where I is the moment of inertia and omega is the angle. So it means that Earth will start rotating 4 times faster as compared to defined as 2 by t, where t is the time period. The time period is what will happen if you shrink the size of Earth to half of its size? Well, it's a hypothetical question. Still, it's an amazing question to answer. So let's discuss this one. But why there will be any change also if we shrink the size of Earth? The simple answer is due to angular momentum. So before discussing all this, you should know that what is meant by angular momentum. Angular momentum is related to the rotation of a body, and if we are discussing the rotation of a body, then you should know that what is meant by moment of inertia. Now, if we are discussing the moment of inertia, then you should know what is meant by mass. Now, mass is related to inertia, and what is inertia? Inertia is basically the tendency of a body to resist the changes in its motion. Now, the inertia in this case is related to the linear motion of a body, but we are not discussing the linear motion, we are discussing the rotational motion of a body. So, in case of rotation, we define another term which is called moment of inertia, which is given by mr square, and that quantity signifies the inertia in case of rotation. Now, of course, the body is rotating, so of course it will have an angular speed. When you take the product of this moment of inertia and angular speed, you get something called angular momentum. So this is what is meant by angular momentum in simple words. You can also relate it to the linear momentum of a body, which is used in linear motion of a body, but just the difference is that in that case it is the linear motion and here it is the rotational motion. Now, the best thing about the angular momentum is that it is conserved if the net torque on a body is zero. Now, what is torque? Well, in simple words, if I explain, suppose there is a nut bolt and you're trying to open it using a wrench, then in that case, you're applying a force at some distance from that point, from that nut bolt. You're not applying at the nut bolt itself, right? So that is why that distance and this force, when multiplied together, they give something called torque, right? And torque is responsible for the rotation of a body. Well, torque is required to start the rotation of body or stop the rotation of bodies, in simple words if I explain. So basically I said that angular momentum is conserved, so that is why angular momentum is given by I omega, where I is the moment of inertia and omega is the angular speed. Now, moment of inertia for a solid sphere is defined as 2 by 5 mr square, and which is a universal formula for any sphere, any solid sphere I mean. And of course, Earth can be estimated as a solid sphere. Of course, it is an ellipsoid. Still, we are considering it as a solid sphere, right? So, of course, the moment of inertia of Earth will also be 2 by 5 mr square, where m is the mass of Earth and r is the radius of Earth. So far, so good. So now we will apply angular momentum conservation. So we will get I1 omega 1 should be equal to I2 omega 2, where I1 is the moment of inertia before shrinking it, and omega 1 is the angular speed of Earth before it is getting shrinked, and I2 is the moment of inertia after the Earth has shrunk, and omega 2 is the angular speed after the Earth has shrunk, right? So I1 is equal to 2 by 5 mr square, and I2 is equal to 2 by 5 into m into r by 2 whole square, which is equal to 2 by 20 mr square. Now let's equate these two equations. We will get I1 omega 1 is equal to I2 omega 2, which means that 2 by 5 mr square into omega 1 is equal to 2 by 20 into mr square into omega 2. So from this we get that omega 2 is equal to 4 times omega 1. So it means that Earth will start rotating 4 times faster as compared to it is doing right now. Okay, but what will be its effect? Well, let's see that also. Now, omega is defined as 2 pi by t, where t is the time period in which Earth completes one rotation. Since we knew that omega 2 is equal to 4 times omega 1, which implies that 2 pi by t2 is equal to 4 times 2 pi by t1. So we get that t2 is equal to t1 by 4. Now we know that t1 is equal to 24 hours, since we know that Earth completes one rotation in 24 hours. So it means that t2 is equal to 24 by 4, which is equal to 6 hours. Which means that the dates won't change after 24 hours, but they will change after every 6 hours. So each day will become 1/4 shorter, and which will have a significant effect on climate and weather across globe. And the most funniest part is that you will start weighing much more than you did before. Since the radius of Earth is halved, so that is why the gravitational force has increased by 4 times. You will start weighing 4 times of your actual weight, and that's ridiculous. And this data I'm saying because we know that gravitational force is inversely proportional to the distance squared. Since the radius is halved, so it means that the force is now become 4 times its original value. So that is why the weight will become 4 times of its original value. It's really amazing to think such kind of questions and answer them. So if you did enjoy this video, then please do like, share, subscribe my channel, and please support this video. Bye bye. Take care.